Hello everyone, welcome to the channel and hope everyone is doing good. So in today's video, we are going to discuss about the polars, specific to the Python polars. We'll understand that how Python polar is becoming very popular and why it's becoming very popular. What is the efficiency it brings in processing part, and how the actual process behind the scene happens in a Python polars. So while writing the Python code, if the Python code what you write in pandas, the same syntax, almost same syntax you follow in polars, but behind the scene how the execution happens is very different, which makes polar very fast. We'll look into the behind the scene also. We'll understand that how and what goes behind the Python polars. So this video will be basically on understanding the concept, and in the next video I'll come up with comparison, the use case comparison when we write a code in a Python pandas, what is the efficiency, CPU unit and something, and then how it is compared to the Python polars. If you have not subscribed to my channel, then do subscribe to my channel and spread this video and this channel to all of your friends or colleagues who want to be a part of a data engineer, who want to become a data engineer, or who want to jump to a Gen AI steps. So native Python, when you write a native Python code or you write a pandas code, so that a processing unit or processing happens in the same system, but there are libraries, Python internal libraries, which helps in the processing. But when you are using polars, Python polars, in that case, the processing is not handled by the Python. We are just writing the code in the Python. The syntax remains the same. We are using the polar Python APIs to write the code, and actual code is getting executed inside the Rust engine, because Polar is created on the Rust engine. So what is the Rust engine? So Rust engine works on query execution, runs on parallelism, like your task is divided into small chunks and the parallelism happens there. And there is in-memory processing there. There is a vector database, vector file format is being used there. So the Polar engine, understand it like this. There is something called Polar engine, okay? And Polar engine, inside the Polar engine, there is a processing unit, which is the Rust engine, and Polar has created multiple APIs for multiple languages. For example, it has created for Python, which is becoming very popular. So we call it a Python Polar. Similarly, we have the Polar API for the Rust. We have the Polar API for the language R. But Polar API for the Python is very popular. Now, to interact with the Rust, we need something. We need something which can understand our Python code and can make it understandable to the Rust engine. So for that, we need some API in between, so that our Python code can be given as an input to the Rust engine. So you can see the flow here. You write the Python code, and that Python Polar API, with the help of Polar API, that code is submitted into the Rust. Rust does all the execution, and then it gives you the output. It's very fast. We are going to see it practically. Now I hope you understand like what is Polar. Okay, we'll see more into it, and I think then it will be becoming more clear to you. Okay, now like when we are writing a normal Python code, like for example, I have written a Python code. We have read a file that in the pandas df, and then we are doing the group by. So when we are writing in a Polar, the syntax will remain same. So I have written here df.group by. So how does Polar engine actually work behind the scene? Native Python libraries are there which understand this group by. There is a implementation of group by inside the Python libraries, and that will understand what to do in the group by case. In case of Polar, how it happens is there is a Python. You have written the code. There is a Python API which uses Polar Python binding. There is PyO3, a native extension boundary, and then there is a Rust Polar code. This is the Rust engine which actually works on your group by statement, and then it works on the native machine and gives you the output. Now this py3, or the native pyo3 and the native extension boundary, this means the interaction between the Rust engine and the Polar Python or the Python API. We need something which can understand our Python code, or which can make the communication between the Rust and our Python API as a seamless part. So that is done by PyO3. This is not a part of the Polar, or this is not a part of a Rust. This is a very totally different technology which creates the binding between the Rust Polar core and the Polar Python API. Right? I hope this you understood, like this flow. if you see the flow of a normal Python, you will not see this polar or any kind of processing unit which is apart from the Python libraries. But in polars, we have a specific execution way, or a specific execution engine, which is Rust polar core. Okay, which is Rust engine. Rust engine has the advantage of doing the parallel processing, doing the in-memory processing, and working on a file format which is vector file format, which we'll discuss later on. And that file format is very popular and very efficient. So now what is PyO3? So PyO3 is a Rust library that allows Rust code to interact with Python, right? The Python which we write, and that Rust can understand that Python. So this library does that work. And this is not a complete part of, it's written here Rust library, but it's not a complete part of the Rust. It's a different technology which is able to do this thing. So it is used to write the, it can be used to write the Python module in the Rust. It exposes Rust functionality classes to the Python, so that when we write the code in Python, that can use the Rust capabilities. It converts the Python object to the Rust type. Rust type is a different way of a different type. And then when we write a Python object, it needs to be interactive with the Rust type. Then it convert when the processing in the Rust happens, then it converts the Rust result back to the Python object. Okay. Now you can consider PyO3 as a bridge between the Python and the Rust engine. So anything you have to write in Python, make it understandable to the Rust. Anything which comes out of the Rust, make it understandable to the Python. With one example, I want to showcase that the actual computation after processing happens in the Rust engine. It doesn't happens in the Python libraries. So now this is the Rust code. I've copied it. This is the Rust code. So this Rust code is there's a logic for adding the numbers, adding two numbers, and a function has been created which and this function has been created which tells PO3 to expose this function to Python. So now this whole thing is written in Rust. Now the work of PO3 library, or you can tell the independent thing, is to expose this add functions to Python. So when you call it from Python, so once the Rust code is compiled into the Python, when this code is compiled into Python, then this particular add underscore number is being exposed to Python, and that you can directly use in the Python code. So this is the Python code. Result equal to my Rust module dot add number. Okay, so this add number is being work here. Okay, it is being worked on in this Rust engine. So this part is not being exposed to Python, only this part is exposed to Python, this add numbers. So that means what you write in Python when you're using Python polars, so that you're calling the exposed function of the Rust, and the actual computation happens inside the Rust engine. It doesn't happen in the Python. You can see that we are just calling it, and that call is happening to the Rust engine, not inside any of the internal libraries of the Python. The same thing in the flow, like with the Python, you call this function add numbers. The PyO3 binding actually this PyO3 binding exposes this add functionality from the Rust to the Python, and then that computation happens inside the Rust engine, Rust function. That computation happens, and then that output is given back to the Python. That means your actual work is being done in your Rust engine. Right. Now we'll see that how this is getting embedded into polars. Now what we have discussed just now is there is a Rust engine, the functionality inside the Rust engine. PyO3 enable the interaction between the Python and the Rust engine. So then how polars comes into the picture, what advantage or what smoothness polar gives in this full process, we'll look it in now. So now you're seeing the polar way of writing the code. So what we are doing the group by on the reason. Okay, and we are calculating the sum on the cells. Okay, group on the reason and calculating the sum. The syntax is same if you would have written in normal pandas, but we are using the polars here. Now this is the beauty, like you don't have to write in a different syntax. You are writing that syntax which is very similar to what you used to write. Now in the initial go, if you see this, it looks like there's a Python. You're calling a Python data frame df, and then with the Python group by function, you are doing the aggregation. But actually, when you're using the polar libraries, what happens is there's a Python code. This is my Python code. You're calling the polar Python API. And there inside that API, there is a binding between Python and the Rust that is done by PyO3 library or PyO3 technology. Then Polar Rust core is there, means this is the Rust engine, because Polar is built on the Rust, as I have told in the beginning. So in the Rust engine, there is the data frame operation happens, that expression what we have written, that will happen, then aggregation is going to happen, the summation is going to happen, and all these thing happens in the parallel execution. You can see the chunks also when you are writing the polars, and then that is passed to the native machine, native Python, and your output is given. So if you're using Polar, this way the execution will happen. If you're not using Polar, if you're using normal pandas, then this way the execution will happen. Let me show you. I have one code in which we can see the chunks also. Let me show you now. So now this is the Polar simple code. I have already created a Parquet file, sales.parquet, and it contains around 5 millions of data. Okay, this practical setup I'm doing it for the next video, in which I'll do the comparison between the normal pandas and the polars, and efficiency what the polar brings. I want to showcase in the practical aspects. But now I'll show you the number of chunks. You can create a number of chunks, or you can read how many number of chunks are there when you use the polars, because as I mentioned, Polar inside the Polar Rust is being used, and Rust work on the parallel processing. So for the parallel processing, we need to have the chunks of the data. So now you see, I'll run it. I have run it now. So you can see that 163 chunks has been created. Okay. In normal Python, you cannot see that chunks. Right. Okay. Okay. I want to show one more thing. Like if I am running this is a pandas code. I'm doing the aggregation on the region, and doing a group on the region, and doing the aggregate of this. So how many seconds it takes? Let me check it. So okay, I have done the print of the result also. See, it took around 1.7 seconds, right? So if I do the same thing in Polar, so this is the Polar code. You see, the same thing I'm doing. The syntax remains the same. I'm doing it in the Polar. I'll run this code. So now this has taken 0.1 second, or consider it 0.2 seconds. And without Polar, it was taking 1.7 seconds. While running the code, if you go and check the CPU, you will see that in Polar, the multiple cores will be being used if your system has multiple cores. And in normal Python, if you have the normal multiple cores, then also a single core will be used, because there is no distribution of the task. Fine. I hope you understood the difference. Okay, the actual practical will come in the next video. One more important thing I want to discuss is regarding the lazy evolution. Like in Python, when you write the Python code, it's an interpreted language, so your code gets executed. In the Polar, what happens? The code get compiles, and it is submitted to the Rust engine, right? So in that case, Rust works on a lazy evaluation format. If you already know Spark, so you know that whenever any action is called, then only your code gets executed, or the code is in the execution form. Similarly, when you're using Polar, it's a lazy evaluation unless until you perform any action like .collect or print or something, any action. But before that, the code will not execute it. And in that case, it gets the way to create the query optimization way. For example, it will create a logical plan. Your Rust will create a logical plan. Then it will, from the logical plan, sorry, it will create the query optimization, like predicate pushdown or projection pushdown, and then it will create a physical plan, and it will be getting submitted to the Rust execution. So in normal Python, there is no such way of the logical or execution physical plan being created, or query optimization being done in the backend. But when you're using Polar, the query optimization is also being handled, right, by the Rust engine, by the Polar framework itself. So one more example we want to discuss, like this is a Python code calculating the total and all this filter value, comparison value. So what happens in normal Python? The iteration will happen. We'll read through it, do the comparison, do the addition, then again iterative, and then again do the comparison. Fine. Now the same thing when you submit this thing to the Polar. Okay, when you're writing it in the Polar, so you don't submit it. That Polar framework itself takes place. It does take care of it. So when you write the same code in the Polar, so then dot filter is being created, is done. Then the select is also done. What process we want to do it here? What happens is Python describe the operation in the Polar, submit it into the Rust engine, all that like vectorization operation. This is the kind of file format we'll discuss in the next session. Then parallel execution aggregation, it happens here. So here you see one by one everything happens, and this is because of the Python interpreter. And here the things is being compiled and being submitted to the Rust engine. So Rust engine is the code. Like Polar, a company has created a Polar on the basis of Rust engine, expose it to the Python, so that Python people developer, like there are a lot of Python developer, and that Python developer can use this Polar to do the same. Now the use case, you understand this use case. Like if you have very big data, very big amount of data, very dynamic data, obviously the solution is still is Spark. You will have to go to the Spark. But you have big enough data, but you don't want to go to the Spark. It can, you don't, that doesn't qualify for the Spark. But you want the performance in your medium size of data. In that case, you can use Polars. In Polar, you don't have to invest anything into the infrastructure, but in Spark, there need to be a cluster, either in the cloud cluster or in the physical cluster. So if your data is of mid size and you want to perform the things fast, go with the Polar. If your data is very big, then you and dynamic, you can go with the Spark. So finally, the complete picture how it happens in the Polar is you write the Python code, like this is your Python code. It gets submitted into the Polar Python API. Then a data frame expression being calculated there. Lazy evaluation framework is there. API call is there. Then there is a binding of Python and Rust binding, which is done by PyO3. And then it gets submitted into the Polar into the Rust engine, where the query optimization, this is the query engine, expression engine, data frame operation happens, memory management happens, and parallel execution. And finally, it is the result being submitted into the machine where it has been called. Right. This is the actual code with the run which happens in the Polar. So I would suggest everyone to try, like you write a Python code in multiple of your project. Try to use Polar. You just have to import Polar libraries, and try to do it with the Polar, and you can see the difference if your data is of large size. So this was all about today's video. I wanted to keep this session short because I wanted to showcase the concept and what happens behind the polars, Python polars. In the next video, I'll come up with a comparison between the Python polars and the normal Python pandas, native Python. Fine. Try this, explore this, look into the vlog, go to the official website of the Python polars. You will know to understand multiple things. Not only Python polars, it is available for. I came to know that it's also available for some of the module is available for Node.js. I'm not tried this, but for R, yes, R it is available now, which I have seen in some cases. Any doubt, any conceptual doubt, please post in the comment. If you have any doubt in my previous videos, so then also post in the comment. You can write me a mail. You can connect me through LinkedIn. Till then, happy learning and goodbye.